Okay, can you hear me now? No. Oh. But then I'm not muted. Maybe because this guy is sharing. Okay, stop sharing. Can you hear me now? Yeah. Now can I? Okay, because it was shared. Hi. Hey, Dimitri, can you hear me?
Yes.
Oh, okay, thanks. I was a bit confused because
yeah,
I can't take the sound. Okay. Hey, hi, Lena.
I see you muted, but I can hear you.
You can see
because
me, right?
Hi, I'm on mobile, so I'll be here quietly.
Okay, so what I'll do is I just put in the co-host so you can say hi. I will remove the co-host from you so there will be no confusion. Okay.
Yes, please don't make me a co-host right now.
No, it was just to say hi. I'm not going to give you extra word. Bye.
Okay. I'm very excited to see your presentation.
Thank you so much. Thank you so much. Talk to you soon. Bye.
Yeah.
You go. Okay, Dimitri. Just very quickly. Let me just stop the recording first, but I don't really need for now. Hang on. So what I'll do is I will just I'll just introduce you, okay? I'll just say hi, first introduce myself, who we are and so on, and then say Dimitri from SAFE is here with us, and hi Dimitri, and then just pass the call to you. Just you spend, I don't know, 5 minutes, and you can say anything you want, and then just say, I'll let Elias continue with his presentation.
Yeah, but what actually do you want me to say? Just a couple of words, what is coming with your presentation, or?
About safe software, and this presentation
okay.
is going to be about, creating dynamic pages and doing some other stuffs, other transformations. It's a basic presentation, for those people who want to know what we can do with FME. That's about it. Something like that.
Okay.
Hi, sorry, we were cut just now. Tadi boleh dengar? Just cut. Sorry, Dimitri, we got cut. I received a call just now. Actually, let me just see if I can very quickly remove that. Okay, never mind. Okay, can you hear me then? Dimitri?
Yeah, I can hear you.
Okay, you can hear me. Okay, then I will put back the presentation and continue the recording, all right? Thanks. Okay. Ini mana? Tak boleh dengar. Oh. Hey, good morning, everyone. Can you hear me? Yep. Okay, we are going to start shortly. Hi, good morning, everyone. I would like to welcome you for our presentation. And thank you very much for coming. So our company is GIS Innovations Neighborhood. My name is Lias Mokrawi. I would like to just to explain roughly what we are going to do or present to you. But before that, we have with us Dmitry Bag from Safe Software. Hi, Dmitry. How are you doing? Thanks for coming and joining us.
Hello, everyone.
Hi. Dmitry. Maybe you can, I think people know you anyway. Would you like to give a few words?
Well, thank you, Lias. Well, Lias, as an old partner of Safe Software, we know him for many years, and we're always glad to see him in Vancouver when we have our conferences. But well, this time it's a little bit different. Still, it makes it probably even more exciting because we are sitting around the globe and talk to each other, and it's an interesting experience. So many of you probably know what I do at Safe. I work a lot with new technologies, experimenting with stuff that is being added to FME, such as augmented reality, artificial intelligence, computer vision. And those are the topics that Liz is going to touch in his presentation. This is why I find it very interesting. And maybe not all the parts are done with FME, but FME is like a universal glue that holds this all together and allows all those different pieces to work together. And I find it's very, very nice and interesting presentation. So I will be helping Elias with questions and answers. So if you have any questions for me, then yeah, feel free to ask. Thank you.
Okay, thanks a lot, Dmitry, for the presentation. Oh, sorry, for the introduction. So just very quickly, this presentation comes in 3 parts, and if each part is about 20 minutes, or maybe a bit shorter than that. So what we'll do is we will stop, and then you can ask questions. If there are not many of you here in this presentation, then perhaps allow people to ask their questions directly without typing those questions in the chat box. I think that would be easier and nicer when we hear the voices. Yeah. So let's start. What we have been doing for the past year is something very exciting. We have created a web app, it's more like a platform. And this platform is being used for, let's say, for crowdsourcing data, basically. So crowdsourcing data, including, we can change and put any kind of request from the people, any kind of information, and then make them submit the information that includes pictures, location, any other attributes. And at the same time, we will be able to process the data in a certain way. And we are going to show you some of the tricks that we have used and some tips as well, and why we have done this over other other ways to do the programming. Okay, so let's get started. So yeah, my name is Lias Mokrawi. We are based in Malaysia, and our website is gis.com.my. So you all know FME, and in FME, the basic things that we have a reader here. This is a reader. It can be any kind of data that we stream, and then we use the FME pocket knife, to do any kind of transformations and any kind of processing that we want, and then we export that into using the writer, and it can be any database, it can be any kind of flat files that we want to share, to save into. So why did we decide to use a web app and not anything else? Well, by definition, a web app is an application software that runs on a web server And unlike any other computer-based software which are being used in a computer itself, can be the phone. The reason why we have done that is, well, mainly to get away or to avoid dependencies with all the operating systems that we have for smartphones, well, mainly Android and iOS, of course. So our platform is called CCAM1. Okay, so it's a crowdsourcing platform and developed with FME platform integration in mind, meaning that, okay, it can be used standalone, but if you want to use FME Desktop or server or, you know, or cloud, yes, you can do that as well. You can just grab the data, and it's very easy to grab the data. We will show you how we did it later. So this is what people have. It looks like an app, but it's not an app. It's actually a website, right? So people can log in and with a username and password, and then you have all these kind of tabs, camera, track, if you want to create a track, or if you want to view the map. And we have added something else, AR component, which we are going to show you later on. Okay, so this is how it looks like. This is the view from our office. Basically, well, people just, they view what they have here. They want to take a picture of something, can be anything like a porthole or something that doesn't work. No, and then they just take a snapshot. And when they take the snapshot, they just click on send. So we have made it very easy for the people with little knowledge in IT to operate this. So how is the data transmitted into our server? It's sent via email. So we will send via email, and then, you know, the email will go through the cloud, and then it will be dropped in our server. So it doesn't matter. Then later on, it can be processed with FME Desktop or server or cloud, or even, you know, meaning that once we talk about FME, that means that it will be processed by itself, not by itself. It can be automatically processed. So what we have is we have the input, which is the email, the attachment of the email, and then it will be exported to either AR3D, GeoJSON, or even HTML pages. We are creating dynamic pages from those emails that we receive. So the data is stored, and then we just call it the popcorn database. Sorry about that. Just to say any kind of database that you want after processing. And yeah, well, you get the idea. So as long as FME can receive the data, can read the data, we can process it in anything that you want. And as a result, when people click on the map, they will have all sorts of data updated. And we will have a pop-up as well that we create dynamically to view. And the pop-up will include the user. Well, as you know, if you use FME, we can always use FME to automate that, but we don't want to do it that way. We need to check the pictures, what people send, so, you know, so just to make sure that people don't send a picture of their pet or, you know, the cat or anything like that. So we need to check that. But we can always, pardon me, we can always use FME to process the data, and then you know, automatically, so we can have real-time dynamic images in our map. Okay. Something that we have added is we have added a small AR component. Okay, this AR component is it shows the points that we have with the elevation and so on. So how did we do that? We just used Blender. Blender is an open source software for 3D. It's a very powerful software. And we created the model, and from there we can include that into our CCAM or our crowdsourcing platform so people can view. Why did we do that is more like if there's a pothole somewhere or if there's a tree, something specific you want to depict in the map, it's very simple. People just go to that place, but they will search for the, let's say the tree or the pothole, and then when they click on AR, you will know exactly where it is, and then you can just go to the specific item to investigate. But this is very simple. It's not like what Dmitry has been doing. It's just very small points. But this is all web-based, all right? So it doesn't require anything from your iOS or from the from iOS or the Android smartphones. So to answer to a few questions first, I mean, is they say, why did we use a web app approach and we did not create an app? Well, we can definitely convert this web app anytime into an iOS app or into an Android app, but we don't want to do that because the way it is, we have gone away with all the permissions and most of them. What we need is just to rely on the browser. So it's tested on Firefox for Android, on Safari, and also on Chrome for Android or for iOS, and it works very well. So we can convert it anytime to the CCAM platform into an Android app or an iOS app, but that is not the direction that we want to take. And this is really open to anyone to access these platforms. So why did we use email to send the data? We find it more efficient, and we don't have to rely on how to connecting and all these kind of issues that we have. And it's very simple for us to create, let's say, a GeoJSON or JSON file. We will take that file and attach it to an email and send it to the server. As you know, let's say if you use Gmail, you can set any email address. Well, FME server supports downloading attachments for an email. That is achieved very easily, right? Or alternatively, instead of using FME server, there are a few applications or software available that allow you to drop the attachment of emails from a server into a specific folder, and then processing that automatically using FME Desktop. I'll continue this. So this is the part one of our presentation. In part two, we are going to go in more details about how things are processed and a few tricks that we have used during the development of this platform. Okay? One moment, please. Sorry. Sorry about that. Okay. Yeah. So if you have any questions, you can send me an email, drop me an email. But there are not many people in the chat. So what I will do is I'm going to unmute everyone, and if you want to ask your questions, you can do that now. Hang on a second. I'm going to. Okay. So if anyone has a question, you can just unmute yourself and ask me the question directly. If anyone has a question. If anyone has a question, you can just unmute yourself. Not yet. Part two has not been presented yet. So you just go part by part. So if there's no questions, then I will just go ahead and continue the presentation. All right. So in part two, okay, so for those who were not here for part one, we are from GIS Innovation based in Malaysia. And we are talking about how we integrated the data, some of the data with our web app that we have developed. And there are some AR and AR components as well. Okay, so CCAM1 is the name of our web app developed crowdsourcing platform. So what we have said just now is that we can, what we do is when people take pictures or they want to send information, it is being sent via email, and then the attachments can be dropped into a folder for processing, or we can use FME server to process that directly. So this is the app. So I've explained that we just take a snapshot and then send, click on send. But how did we avoid all the dependencies from the iOS or Android? So this is just a snapshot of how the data is being transferred to our server. And you can see here, we have a JPEG image and a very long file name. So if I zoom in here, this file name contains all the information that we need. So here, this is the ID of the user, the app code, timestamp, longitude, latitude, and other details such as elevation or any other information that you want to add. So this is one way to get the information from the picture instead of using EXIF and embedding the information inside the picture. So how does it work? Once we have data which is dropped into our server or into our folder, then what we do is we just take the information and we will take the file name and process it to convert that into a database. So as this is how our workspace looks like. It's a very simple workspace. Well, we are going to go into more into details on how this is being processed. So first thing we do is we use the attribute splitter. When we take the file name, we use the attribute splitter and we use a certain this and two underscores, which are delimiting the information. And once we split that, we have a list of the different attributes. And then we use the attribute renamer. and give them more meaningful names. Okay. So we use the, like for example, list 0, we know that it is the ID, and the date, longitude, latitude, and so on. And every time we receive a picture, it will definitely have a unique name. So there's no worries about that. And what we can do is once we have the information retrieved from the file name, then we will be able to do a lot of things with the information, just not only to, since we have the coordinates, for example, we can convert that into points using the, using the transformers for that, like the vertex creator. And then what we do here is something more. What we do is we create a link dynamically. I'm going to show you this. We even create a Google Map link. So once we process the data, this is what we have. We have the information here, this bubble, or this balloon, sorry, and we have the picture which is shown dynamically inside our CCAM platform. And we also have a geoportal which is linked to this, but that is just showing maps. It is this, but web-based. So how did we convert the data into links? In short, what we did is we used the attribute creator. From there, we just added the information. Like here, you can see the value from the FME base name, meaning that we keep the same file name, which will be read from our server to display the information on the map. And this is also something that we have created. It is work in progress, but it's just to create a Gmap or Google Map with the point of interest, the POI. So the users can just click on that point or the link, and then they will be able to drive to the location. So we process the data from the email, and then we will export that into anything we want. But here we are exporting this to AR 3D model, GeoJSON, or the HTML pages. Okay. Just a moment, please. Huh? Okay. So the data is being processed in our FME, in our server containing FME, and exported into our database. So this is how the data looks like. These are two screenshots taken from QGIS. Okay, so you can view that in any desktop GIS that you are using. This is actually a long table which I had to cut into 2 pieces. But the most important thing is that we have an image with a full link here, and also the Gmap link created dynamically using FME Desktop. And I think when you try to process data in, let's say, more details, then you'll have to use FME. I think is a better tool to do all sorts of processing on the data. So because this was added recently, so now when people click on a point on the map, they will have also the Gmap, meaning Google Map link that will appear in the pop-up of the web app. Now, something different. We were talking about, some of our web apps have an AR tab. So this AR tab is, just for the people to see where is the item that they want to view. or to reach. So how we did it, we just created, as I explained earlier, it's just a GLTF file actually, it's a GLTF file. We use GLTF, they have two types of formats. One is JSON or just ASCII, and the other one is binary. What we do is we use the ASCII format or the JSON format for further processing when we want to change anything. But there is a small issue in our system because FME Desktop does not read GLTF, but it writes into GLTF. So in terms of processing, we had to find other ways. Well, but with FME, many things can be done. This is the ride on the on the stream of our workspace. So this is how our workspace looks like. Actually, this is a different workspace. When it comes to AR, it's a little bit more tedious. We had a lot of things to change, a lot of things to amend, and so on. But what I wanted to show is that for example, we had to change if we wanted to change the color of the GLTF model, the 3D model, we used the trick that we did was we opened the JS file, the JavaScript file version of the GLTF. We opened it and put it as an ASCII inside. We loaded it as an ASCII file or text file inside FME Desktop. And then we processed it as a string. Why did we do that? Because we can, of course, because FME can do that. And it's easier. And there's just a small portion that we needed to change, which was to change the color of the 3D model. I will show you later on how we did it in the next slides. So we had to do a few things like cleaning the data and so on. This is something very basic that you can do with the FME Desktop, especially when it comes to cleaning text file strings. Yeah. So how did we change the GLTF model color? Well, we first created an attribute, and that attribute had a multi-line file containing the ASCII file of the GLTF model. So from there, this is a slide that I added for Dimitri because he likes 3JS and we were talking about colors. This is a subject that I'm going to talk about shortly. Because GLTF, we need to have sRGB instead of RGB colors. All right. And so let's move on to the next. Dimitri, that's for you, okay? You say thank you later, not now. So this is our main dashboard where we change stuff that we want to change. Like, for example, this is all done in FME Desktop when we first run the workspace. Like the maximum buffer is how many points we can have around us when we use the AR app. 200 is, you know, it's too much because it depends on your phone, and there are a few things that you need to take in consideration. Like the GPS refresh rate is every 5 meters. When we walk, we refresh the 3D models and so on. These are just internal to us. And then we had this added, which is the to change the color of our 3D model. And this, I just want to give a remark for those who are using FME 2021 and they are creating their own transformers. This has been improved a lot since 2021, where we can change the order of all these items the way we want. And that can be very useful, and there's less frustrations when you say, why is it that we have the date after the the ID or after the coordinates, and the coordinates should be together. But now with FME Desktop 2021, you can rearrange these the way you want, and I think it's something great. Anyway, let's go. This is the color picker that comes as in FME Desktop. You can get this from the parameters that you want to create. So when we click here, we will have this that opens, and this is in RGB. So I need sRGB. So how do we do the conversion? There is, just want to show the three dialog boxes. It's not that hard. Well, sRGB is a chart, okay? But if we have to look at the chart all the time is a bit of a problem. So some people give me the formula, which gives you something not far from the sRGB. Let's say converting the RGB to sRGB. This is the formula. You can just pick it up later from the recording, or if you have any questions, you can just let me know. But in short, this is how we converted from RGB to sRGB. And then this is something else. How did we create the page dynamically? This is because every time you see that it's all JavaScript components that we have to update whenever we receive data, and we need to update those dynamically. So whenever, this is what I like about the web app. You just do the updates centralized into your web server, and whenever somebody logs in, they will log in with the latest version that you have. They don't have to update. They don't have to worry about many things. But the two things that you have to worry about is the permission. The browser needs to get permission to access the GPS, and it needs also permission to access the camera. That is something you cannot get away with. Okay. So how did we create the pages dynamically? So we just replaced the strings. Basically, web pages are HTML. You have JS files, you have JavaScript as well. It's all text. So what we do is we just take a text and replace information with all the information. Sometimes you need to add more information, then you have to iterate through all the features one by one and add on. Once you have added on your data, what you can do is once you are done, then you add the header of the page, the footer of the page, and you are done. So just an example, because what we need is three components. We have the data file. This is the AR data file. It's AR.js. And what we have is, we just export it using the feature writer. It works very well. That's how I like it. And then we have the web page file, the web page itself that needs a JS component included. It's a script actually to read the data for the AR model. So we do the same thing. Once we convert that into a text, we export it as a text file, but we put the .js extension to it, and we use the feature writer as well. And then we have other things. We have the message box file, meaning that when you have AR, when you click on the model, then a message box will appear to give us more details. That is a bit overstretched, I find, but yeah, we did it because we can do it. So the same way we have an AR message, you just click, go for AR.message.js, sorry, we select the name AR message.js, and then we export it using the feature writer. So this is these are some of the techniques that we have used. We find it very easy to grab information and export it this way to make our pages as dynamic as possible. Okay, so this concludes part 2 of our presentation. Do you have any questions?
Hello. I have a question regarding the picture. So currently it's static, right?
Which slide do you want me to? Is it the AR or
the pictures? The
picture. Yeah.
Yeah.
Like this.
So yeah. So what if the picture is coming from a live camera? How would that change the entire code?
Okay.
Like possibly
Right, it's very simple. We don't use. You mean the cameras from the phone or a live feed?
like a live feed, like if you
Okay. Okay.
put a camera in there. So
Okay. Let's say. Okay. Imagine that this is your mobile phone. Okay. This is how your mobile phone, your browser will look like. So what we can do is we will just you choose what you want to take, the picture you want to take. So this is a mobile phone only. We are not talking about CCTV. It does not support CCTV. And then once you want to grab, like as if you take a normal picture, and and then you, when you click here, just a moment. This is how it looks like. Then you click on take a snapshot, and then the photo will freeze, or the camera will freeze. So that is the picture that you have taken, and it is saved in your phone. And then when you click send, it will be sent as you see it here. Okay. Does it?
okay,
If you're not happy
okay,
with it, just retake, and you can see it as a normal camera.
okay, all right, sounds good. Thank you.
Okay. Thanks. Any other questions? Anyway, okay. If there are no questions, I think we are going to finish our presentations a bit earlier. And please feel free to send me emails if you have any questions. Part 3 of our presentation will describe the method used to process, sorry, it's not AR, but AI. That was a mistake. AI and object detection, okay? And what we want to show here, so okay, if you have any questions, you can just send me an email, all right? I'll be happy to answer your questions. So now what we are doing is we are going to talk about AI. AI is artificial intelligence, and we are going to talk more about object detection. This is a subject or something which is really on vogue now. A lot of people are doing that, and you have a lot of ways to create, to do your to develop your own AI system. But I just want to show some of the tricks that we used to integrate with FME Desktop. So whenever I say integrating with FME Desktop, that means also integrating with FME Server, with FME Cloud, and also to be able to convert your data into any format which is supported by FME technology. Okay. So I've spoken about this already. Okay. My name is Lias Mokrawi, for those who just joined us. Working for GIS Innovations, sorry, we are based in Malaysia. So part 3. For those who just joined us, this is something part of our CCAM1 crowdsourcing web app that we have developed. So it's for crowdsourcing. So just to enable people to crowdsource information. I see the lizard knows about it. He's already on it. And yeah, we are going to talk about object detection and how we use FME to process our data. As explained earlier, so our data comes via email, and then we drop it into the server. So when I say drop it into the server, you could be using FME server to download the attachments, or you have a few available free software that help you to download attachments of emails, or you can use PowerShell to do that if you like PowerShell, which is is as powerful as the name says. So what we do is the email is dropped into our server. It doesn't matter what server it is. And so what we have is we have three main formats. The formats are images, JSON format, and also GeoJSON formats. Why did we use GeoJSON and JSON? Well, because most of the software can read these formats, and it's in terms of just to be open with the data, and it is very easy to process the data that comes in GeoJSON or JSON formats. So this is the part that I've explained earlier, but now I'm going to talk about the object detection. From this server, we can take images and then process with our object detection box. From there, what we'll do is we can use either FME, or we can just directly save our server in data in our server. Okay, how many data there? I'm not really sure. And then we have our specialist, FME specialist, that can read the data directly from the database. And then, of course, use FME to do anything in the network, as long as the person is connected to the network. Yeah, FME is amazing. That's true. There's just a lot of things that you can do with it. So how did we do our processing? To process the data is, once the data comes, it goes into this object detection box. Okay, we are not getting into details on how this has been done, but later on I'll just give you some tips on how you can have your own object detection box. So once we have this, the FME could process the data if we want to, or just you can just save it directly into your destination folder. In short, we have spoken about CCAM, and CCAM drops images, and we will process that. But this object detection box can do more than using the CCAM images. What you can do, you can use any rasters, can use videos, just video files, can be AVI or I think MP4 as well, but we mainly use AVI. You can use video live stream, or when you say video live stream, meaning that if you have, if you are streaming videos into your computer, you can grab that and process the data. And you can, of course, use camera live stream like CCTV or drone. Drones can have a live stream as well into your computer. As long as you have the IP address of the stream, then you can grab that. You can use your mobile phone as well, the camera from your mobile phone, or just a webcam. So the data can all be processed into using our object detection box. Then we can store the data using FME, or just push it straight into the data the database, as long as we can read our raw format. But from here, so how can data be processed? You have two ways. One way is by piping the data and having a live stream of data to the FME for processing. I'll show you how that is done shortly. Or you can just save your data inside the FME, inside the server, and then have your data processed as well. Okay. So how do we pipe the data? What we do is our object detection box has a TCP IP sender, or it sends while processing. The results are stored, that is one thing, but at the same time sent using TCP IP in the network on the same machine. From there, FME Desktop, in FME Desktop, we just use the TCP IP receiver transformer, and then we just have our our data processed the way we want. It's just actually text data, so there's no issues with that. But just remember that to do so, you really need a lot of GPU power. If your graphic card is not powerful enough, well, it will still process it in general when we talk about all this, but it's going to be very slow. So it depends. If you have just a basic graphic card, it will take you like 8 hours to process images and the videos. But if your graphic card is very powerful, it will just take like 20 minutes. And if we do live streaming, it will take a few seconds for the data to be sent from your computer into another computer with FME if your GPU power is not enough. So we just process the data, but from here, once we process the data, we'll have the data saved in any supported FME formats. So this is an example that just an example to demo what we can do. This is something like for those farms that have a lot of trees, they want to count the trees for tree counting. So in this example, this screenshot was taken this is a data inspector. So this is just an image, a raster image. So what we have is we need to count the trees, all right? So this is this is just some intermediary data that we have. This is ugly and we can't do much with this. And what we need is, because this is raster and we need to export that to something that we can store into our, let's say, RDBMS for further processing of to create reports or anything like that. So from the initial raster, we would like to have something like this, where we have the points, so we can count the points, we can do statistics, and the location is very important as well. And then we have some small boxes that show the objects that we have detected. So it will look like something like this. From there, it's a lot sleeker than having this, of course. So the box would export the data in some format in a certain way. But before that, it's not that simple to be able to detect objects. So what we need to do is, in the example of counting the trees, usually what people do is that they would take the DTM, and then they will compare with the height of the trees, and then when the height is above a certain number of meters, then okay, that is a tree. But what we do here is a lot simpler, or a lot simpler. There's still a lot of work. What we do is we tell the system that, hey, this is a tree, okay? And we have to do that for all the trees. We need to train our model, not only from this picture, but the more trees that we show to our system, saying that these are trees, then the more accurate will be the counting later on. The more accurate will be the detection of the objects. And this goes for anything. Like we have some other examples, like to show when you have a mask or you don't have a mask. So we have to take a lot of pictures of people with masks or people without masks. Same goes for vehicles, where we want to tell, okay, these are the different type of vehicles, motorcycles, trucks, normal vehicle, so we have to train the model. Once we tell the system that these are trees, and it's a lot of trees that we have to put in with our tools, then we can process with different images and look at what are the results. But when we process our data, images or videos, what we will get is something like this. All right, this is text actually, but what you can see is that you will have like X minimum, Y maximum, and so on. So as long as we have the boundaries, we can definitely have points. This is the confidence, like 1 is 100% sure it is a tree, but because we have used one of the pictures that we have used for the training of the model, that's why we have such good results. For demos, it works very well, but when we have live examples, then we know what are the issues and how to correct them. So our intermediary data will be a text file like this, and then we have this image. This image is not really used much, but we use it so we can compare between the results and the raw data that we have. And this is very useful. So these are the intermediary data. So when we process the data, this is on the workbench. This is what we get. This is our workspace. It shows that what we do is we have the information, we remove the data. There's some processing between that we do. Then we create vertices. From there, we can export to any format that we want. But in this specific case, we just export into the data inspector. All right. So just a few tips about if you want to start working on this, meaning to have to be using object detection with FME or without FME. Number one is you need GPU power, a lot of GPU power. Okay, that is really crucial. And then another thing is that we use OpenCV for this, and a lot of Python scripting. So that's the most popular, and also we get a lot of information on the web. So it's easier for us to to modify things, to ask questions, as the number of users is quite high. So just remember that when piping the data to FME or to any other application using TCP/IP, expect a few seconds delay. So far, we had a lousy graphic card. The delay was about 7 seconds from the time a frame is being and an object is being detected, then sent to FME Desktop. Then we upgraded the graphic card. We got a more powerful graphic card, which is not the most powerful. You have a lot of powerful graphic cards around. And we lowered that to something like 3 or 4 seconds for the processing. So meaning that overall, if you process a video, and it usually takes you about 8 hours, when you have a better graphic card, it would take you maybe 3 hours or less than that. So, okay, this concludes our third presentation, part 3. And if you have any questions, you can ask me. But before that, I just want to share with you something which is our presentation bloopers. So just for fun, it's not, sorry, I had to do that. But please, if you at the meantime, if you have any questions, please do. You can unmute yourselves and ask me the questions.
Hello again. So
Hi, Willie.
I have a question about the object detection
Sure.
module.
Yep.
So you
Sorry, it's breaking up. It's breaking up. Could you please repeat? Hello.
Sorry.
Could you please repeat?
What's that?
You were breaking up
By
just now.
torch or hi.
Willie, could you please repeat your question? Oh, okay. Your question is, can object detection be done in FME 2020? Is that your question? Hello? Oh, okay. Sorry, that's Gavin. Gavin, Willie, can you please type your question in the chat box? I will answer Gavin's question first. Object detection is not done by FME at all, right? So I think Dmitry can give you more information later, can answer your question. But what I want to tell you is that what we did was we did the object detection outside of FME. And then we have converted all that stuff using our object detection box. And we piping data, meaning sending the data through TCP/IP and process the data in FME server. Okay, so not FME server, sorry, FME Desktop. One moment, please. Okay, so yeah, so what we do is we have the data, any kind of no rasters and videos. We just use that to send to our object detection. The object detection box, all right, or application will send to the using FME into our server. Okay, so then the data itself, we will have intermediary data, which is this, and then we will grab it using FME Desktop, and we will be able to convert that into something more meaningful with FME Desktop. Does it answer your question, Gavin? Okay. So is Willie back?
Oh, yes, I'm back. Sorry about that.
No worries. Yeah. So what is your question?
So the object detection module. So for each object, you have separate Python modules, right? Like for detecting trees or for detecting cars or for detecting.
It's the same module. It's just that, okay, the way it works is, I didn't want to go more, to do more details on this, but sorry, I have to take you back in this. Oh, sorry. Just a moment. Let me find my slide very quickly. Okay, so the way it works is like this. Can you see this slide with the arrows? I counted them. There are 23 or 24 arrows. So the way you do is there are some third-party tools. Then we have modified a bit. It's open source. You can find that anywhere, everywhere on the web. So what we did was we had to basically crop each tree and say, man, this is a tree. Then okay, then, hey, man, this is a tree, you know. So we had thousands of trees, something like that. And from there, we created what we call a model. So that model is for the trees only.
Yeah.
So if we want to, if you would like to process the same let's say for trees, tree counting, we have a command line saying, okay, ABC Python, and then tree module export to that, something like that. So if you want to talk about cars, let's say we have built another model talking about that, then every time we say, this is a car, this is a motorcycle, this is a truck, this is a truck, this is a car, this is a motorcycle, and so on. We have hundreds of samples that we compile into a model, and then when we want to run that, we run it, we say object detection Python module, and then you use the vehicles model, and then export it to this and that and that. This is how it works in a few words. Okay, so you need to create a model for anything that you want to detect, but it doesn't mean that you can create one huge model that has can detect trees, monkeys, ice cream, bicycles, motorcycles, etc. You can do that. It's so it depends on what you want to achieve, what you want to detect. From there, you'll be able to know what you want to how you want to process your data. And for example, we can do that with guns. We were going to print a gun, and then so okay, we don't need that. So, but we just took pictures from the internet on guns, and then we created a small model. This can be useful, for example, anywhere when somebody takes a gun, then you have it will be detected, and then an alarm would sound somewhere else. Yes, that can be done as well. Okay, but you need to create a model of the objects you want to detect. Does it answer your question?
Thank you.
Hey, you're welcome. No
Yes,
problem.
it did. I thought there were many. I thought there were many Python scripts for specific objects.
No. But the
There's
underlying
only
layer about
one. Then that's great. Thank you.
It's just one. I mean, the command line is just one, but there are a lot of Python scripts that would do different things. For example, this is for object detection. It can be for colors, it can be for, So OpenCV, it's an ocean of stuff that you can do.
Okay.
But we took what we needed. That's all. Yeah.
Yeah. That's great.
Are there any other questions? Perhaps Dimitri, do you have any question you want to ask?
No, I don't think so.
Okay, all right. Okay then. If
maybe, Liz, do you have any videos with AR to show us how it works?
I need to be. Oh, you mean to prepare or just to show you the
results? No, just how. Yeah, just a screen capture.
I didn't prepare that. Yeah, I can share it. Hang on. Just give me 2 seconds. I'll see what I have here.
Yeah,
otherwise,
sure.
Yeah. One moment. Not sure. I really have to because they are not on my machine. They are on different machines, so that could be a bit difficult. But yes,
no problem. Yeah, if you have something, maybe I'd be curious to see how it looks like.
Okay, we can do a call anytime, and then I can.
Yeah.
All right. Any other questions? Okay, if there are no other questions, I would like to thank you very much for being with us. This recording should be available on the WordFair Hub website. We are going to upload that. And for those who missed out the presentation, they will be able to go back and see what we have presented. Thank you so much for being with us, and I hope to see you soon. Enjoy the rest of the show with our partners as well. And yeah, if you want to contact me, so this is my email address, or you can use this email address as well. I'll be happy to answer your questions. Okay.